I need to find my voice. So, hi everyone, thank you for being here, welcome. Welcome to one of the last sessions of the day. My name is Adina Trufinescu. I'm a product manager for Azure Cognitive Services for Vision. And in this session, I will cover state-of-the-art computer vision and how you can build that into your applications. We'll get started with a quick reminder. You can submit your questions. So if you can scan the QR code to your left, that's how you can submit questions through the session. And then I will make sure to reserve some time at the very end to also take some questions live from me. So with that, let's get started. And the first thing that I want to introduce to you is Project Florence. This is the latest advancement in computer vision from Azure Cognitive Services. It is a large foundational model. So by now, we all heard or tried large models such as GPT or BERT or DALL-E. And the Project Florence, the large foundational model from Azure Cognitive Services, it's also a large model based on transformers. It is multimodal, has capabilities for both language and vision, and it has been trained with a vast amount of data with billions of image and text pairs. And this model is capable, because it's a foundational model, is capable to enable downstream tasks, anywhere from fine-grained, such as object detection or segmentation, all the way to visual questioning answering. And it works on static content, such as images, as well as dynamic, such as video. And like I said, it is multi-sense, because it has vision, language, and soon audio to be added. And this model has a quality that we call open world recognition. So what that means is that with zero-shot recognition, because the model has been trained with this vast amount of data, it can recognize millions of object categories, anywhere from species, landmarks, logos, products, celebrities, and so forth. So I want to actually illustrate what that means with a quick demo. So we are here in Vision Studio. This is the web portal from Azure AI Vision, where you can try vision capabilities with a no-code experience. So let me show you two tasks which are enabled by the language and vision capabilities. The first one is add captions to images. We've had this for a while, but actually in 2020, we've reached human parity for image captions, but the model continues to improve with the large foundational model. So I'm going to try here an image from my library, and this is an image of Times Square that I took on my trip to New York City. And the previous model will tell you, things about the image, but if you read the detected attributes, the output of the model is going to tell you that it is a tall building with many billboards, but it's going to also tell you that it's in the middle of Times Square, and that is because the model has that open world recognition. Another example that I want to give you is a new task that we enable, which is searching photos with natural language. I'm going to talk more about this in the session, but I want to do a quick demo. And we have here sets of images. You can try searching with natural language, even if you are not signed in with your Azure account. But when you are signed in, you can try it with your own images. So I have here my personal images, and I'm going to give it a minute or a second to load, and then you can see pictures with my pets and my trips. So let's see if the model knows like a bunch of things. I'm going to search. So my puppy, it's a Bichon Frise. So let's see if the model can find the images with Bichon Frise. And then sure enough, the most similar images are being returned. And then you can play here with the slider, and then you can see like the most relevant to the least relevant results. So let's try something else. I have pictures from my trip to Bryce Canyon. So let's try that. And then the model is going to return similar images from my trip to Bryce Canyon. This is an iconic image of Bryce Canyon. And did you know that these rock formations are called actually hoodoos? I didn't know until I actually went there. So let's see if the model has the knowledge of what a hoodoo is and if it can find these images. And sure enough, if we glide the slider to the most relevant, it's going to find these kind of images. So this is the kind of knowledge that the model has being trained with that vast amount of data. So let me jump back into the content. And I'm going to talk about this Computer vision use cases enabled by the large foundational model grouped in 3 categories. I'm going to talk about digital asset management. I'm going to talk about computer vision for safety and security. And then we will talk about how computer vision can modernize retail operations. So let's jump into digital asset management. So by extracting content from images, with digital asset management, you can improve search. You can have search engine optimizations by extracting descriptions from images and videos. You can deliver contextual advertisements by matching the user's interest with visual content. And then you can support accessibility by enabling alt text scenarios for users with impaired vision. And the APIs that you use to extract this knowledge from images are the image analysis APIs. I have here 2 of them. I have captions, and I have dense captions. So captions is the one that I demonstrated before. We had this one for a while. And then we've added the ability to create what we call dense captions, which is the one with the video to the right, where we extract salient regions inside the images, and we provide the detailed description of the region itself. So this is the kind of information that you can extract from images. And I've mentioned about the accessibility and alt text capabilities. Microsoft's own applications, like the Office suite of applications, Word, Excel, PowerPoint, Outlook, and then also Edge and LinkedIn, they are all using these exact same APIs to enable alt case for accessibility. And then we've talked about search engines optimization, so let's see how we can do that. You've seen my demo earlier about finding content with a text query. And the state of the art for search up till now, it was based on keyword search, where there was a match between the keywords provided by the user and then the text extracted from the images, which works to a great extent. But the new way of doing search that we are introducing is with the image retrieval APIs, which enable vector search. So let's see what are vectors, also known as embeddings. So the large foundational model is a transformer-based model. As you probably know, the state of the art for computer vision, up until now, it was based on convolutional network models. And now the large foundational models, they are all transformer models. And this introduces the concept of vectors. So vectors at the API level are floating point values. These are real-world numbers which represent point in the highly dimensional space. What you see here in the image, it's a depiction of a 3D dimensional space, but the actual highly dimensional space of the large foundational model has up to close to 1,000 dimensions. Each dimension corresponds to an attribute of the content, and it can be semantic context or syntactic role or context in which it commonly appears. And the vector space quantifies the semantic similarity between vectors. So the way you do that is through methods such as cosine similarity. So we have here the code, which is calculating the angle between 2 vectors in the space. And the smaller the angle, the closer the vectors are together. So the demo that you've seen in Vision Studio before is actually using cosine similarity to find the similarity between the text vectors and the image vectors. So let's see what are the image retrieval APIs that extract vectors from images and text. So we have vectorized image and vectorized text. So the set of images in which you want to search for content, you push through the vectorized image API to extract the vectors. And then you save the vectors into a search index together with the images. And then this search index is something that you will access later on when the user is coming with a text query. The text query is pushed through the vectorized text, and then you extract the text vectors. And keep in mind, because the model is both a language and vision model, the vectors for text and images share the same highly dimensional space. The second step is to measure similarity, and then we've mentioned cosine similarity. Another way is to calculate Euclidean distance, and then you select the top n image vectors, which are the closest neighbors to the text vectors. And then the last step is to retrieve the images corresponding to the image vectors. So managing a search index is quite involved, and some of you will want to do that, and some of you will prefer that that is done for you. And yes, it's a lot of work, and we are actually happy to introduce that there is another service that can help implement the search index for you, and that is the Azure Cognitive Search. So the vector search capabilities for many types of contents, including images, are now coming in private preview. You can sign up today at the link on the screen. And then Azure Cognitive Search is invoking the same image retrieval APIs coming from Vision, the one that I've mentioned, and then they are building the search index for you. Okay, so we've talked about extracting text from images. We've talked about searching images with text content, but the one that I find the most fun is the segmentation API. So you can come in with, you have the API on the screen, you have the segment API, and then you can come in with an image. And then if you remember the times when we manually had to do the work to do the pixel segmentation manually, now there is an API for that. So the API is going to return to you the segmented image with the transparency. And then you can do the work to add the background of choice, and then you create this fun content. Oops, so at this point, I want to actually jump into a quick demo. I clicked forward too soon. So I want to take you to Visual Studio Code, and I want to show you how you can invoke the image analysis APIs with the Vision SDK. The Vision SDK has support for most of the REST APIs in computer vision. Not for all of them. We continue to add support. The ones that I want to show you here are captions and dense captions. And the Vision Studio SDK, it's enabled in, or it's available in C++, C#, and Python. I have it here in C#. So the first thing that you have to do, not shown here, is to create an Azure Cognitive Service on the Azure portal or an Azure Computer Vision resource. And then you have to come in and you have to bring over the Vision endpoint and the Vision key. These are considered secrets, therefore they are not shown here. And then you can run the Vision APIs on a file or on a URL. The file that I have here, it's a sample file. I'm going to show it to you in a minute. And then I wanted to show here, for illustration purposes, that you can come here with URLs as well. And then you select your image analysis options. So you can select the Vision tasks that you want to invoke. So you can see here we have captions and dense captions. But here you can add text, which is OCR, or you can add object detection, people detection, and so forth. And then the last thing that you do is in Image Analyzer, you provide the service options, the image source, the analysis options. You call analyze, and then you print the results. The image that I have here is an image of a family with a barbecue in the background. So let's run the code, and then we can look at the results. Okay, so the return of the caption is a person in a yellow apron cooking meat on a grill with a person in the background. And then we have the dense captions, which are the regions. So you have the bounding boxes with the confidence level and then with the description of the region. So like I said, you can try and build your applications directly with the REST APIs, or you can use the Vision SDK, and then you can have access to these more strongly typed APIs. Okay, so now jumping back into the content. Before I wrap up the segment on digital asset management, I want to call out a success story from one of our customers. So Reddit is using these Vision APIs, in particular image captions, to extract captions from images and make the content more accessible to Redditor users, giving them more opportunities to explore images and engage with the content. So we are happy with their progress, and I wanted to share it here to also inspire you, to use these APIs. So let's jump into safety and security. So in the physical world, there are millions of cameras installed on physical spaces, and the goal is to improve safety and security. And these cameras generate petabytes of video, which are stored, and the time to resolution for a security incident depends on the ability of the person to actually narrow down the search and then visually find content in this video. And wouldn't it be great if you can search video content the same way I showed you before, where you can search images with a text query? So that is now possible, and I want to show you how. So jumping back in Vision Studio, we have here the video summary and frame locator. And you can come here with your own video. And we have here samples videos that we have for you to try it out. So I'm going to pick one from a factory floor. And the first thing that I want to show you is the summary capability. So we can run summary, which extracts text descriptions from the video frames and then puts that together in a nice and tight summary. And then it's going to call out the noteworthy events. So we have here one worker seeing running. We have another worker moving boxes, and then we have a person pushing a fire extinguisher. So let's use a text query to find these video frames. So we have person pushing a fire extinguisher. So let's run the query. And then sure enough, we find the search result. So here in the video, it's going to have like markers where it can find like similar frames. Let's try another one. We have person carrying a box. And then I think one of the things in the summary was a person running. And I don't have that in my preset query, so I'm going to write it. And then he's going to find the frame which is most similar with the text query, which is person running. So you get the idea of like how vector search can actually enable not only image search with natural text, but also with also for video in a similar manner. So let's see how that works. So to the left, we have cameras in physical spaces, and these cameras can stream video into the Azure cloud in Azure Cognitive Services, and then the video is stored in Azure Blob Storage. And then to enable the search capabilities, we are indexing the video by extracting vectors, the way I explained it to you before with the image retrieval APIs. So we sample video frames, and we extract vectors. And in this case, we are building the search query for each video file. When the user is coming with the text query, we are doing the same cosine similarity and finding the nearest neighbors for the text vectors. For summarization, we are extracting keyframes from the video, and then we are running this through image captions and dense captions, and then using GPT, we are putting together the GPT summarization, we are putting together the summary the way I explained it to you before. And then using these capabilities, ISVs or developers can build solutions such that end customers have access to the video search capabilities. But streaming video to the cloud 24/7 from cameras can be quite expensive. And this is where we want to take advantage of capabilities such as smart cameras, who can actually do pre-processing of the video before it's being sent to the cloud. So we are happy to announce our partnership with Axis Communications. And Axis Communications is bringing best-in-class cameras to run AI directly on the intelligent Axis cameras. And they also have the Axis Camera Application Platform that enables running applications on these cameras. So Microsoft has onboarded an application on the Axis Connected Services that can run on smart cameras, and it is integrated with AI models running on the camera itself, such that video is sent to the cloud when there is motion detected, or when there are people detected or vehicle detected. And this has like multiple advantages. It decreases the network traffic because the camera streams video to the cloud only when something interesting is happening, or it improves the storage because it requires less storage, and then it improves scalability because now the compute is also pushed to the edge. So I want to show you a quick end-to-end demo is quite involved, and we have it recorded for you. And you will see how we can set up an Axis Smart Camera to connect video to the Azure Cognitive Services, and then all the way to enabling video search and summarization. So the first thing that I want to, we are running directly into the demo. So you're going to axis.com, and then you select the Microsoft application that has been onboarded on Azure on Axis Connected Services. And then this is created here from the point of view of the system provider. And they are signing in with their Axis account. And then they create an organization, which is a logical grouping to organize the cameras installed in the physical space. And then on the Axis mobile application, the system provider is logging in with the same Axis account. They can find the organization, and they will be using this mobile application when cameras are installed to onboard these cameras into the Axis Connected Services, and then from that point they can move on to camera setup. With the camera setup, they are unboxing the camera, and then on the manual they will find the camera serial number, and then they will scan that with their mobile application, the one that they've been using to sign in, and then to organize the cameras in the Axis organization. And then once they do that, the camera is associated with that organization, and then it's onboarded into Axis Connected Services. The last step is to connect camera to power and internet, and then with the one-click push, then the camera is being onboarded, and then it's being provisioned with the Microsoft ACAP application, such that the camera can start sending video to the cloud. The next step is to configure the camera as a video source in Vision Studio. This is the same portal that I demonstrated to you before. So in Vision Studio, the system provider selects an Azure Computer Vision resource, and then creates a video source. In this case, it gives that a name. We call it Smart Camera Demo. And then we select Axis Communications as the provider. You can see here the authentication with the same account that has been used to onboard the cameras and install the cameras. And now the demo for MS Build organization from the Axis Connected Services, it's accessible on the Cognitive Services side. That one is selected. And the video source is created. And at this point, from Azure Cognitive Services, we are able to list the cameras connected in physical spaces. So we have here, for demo purposes, 3 cameras. We will select the retail camera, and then we will configure this camera with an Azure Blob storage container, such that the video is recorded every time when there is motion detected. We select a container, and we allow Vision Studio to read and write to the blob storage, accept the terms, and deploy. So at this point, the camera, every time when there is motion detected, will start recording video into the Azure Blob storage. And at this point, users can go and actually try the video search and summarization capabilities, which is the last step of the demo. So we can see that one more time. Here, you can bring your own video, and you browse an Azure Blob storage container. You select the same container that has been used for setting up the camera. This is the container where the recordings are stored. We select the video. In this case, we select the retail video. And then at this point, the video is being indexed, which is a long-running operation. This is where the vector search extraction happens, and the search index is being created. And then we can come here to locate specific queries. So the one that we are doing here is person sleeping on the floor. And then this one is going to return the search results with the frames where we have a person falling on the floor. So let's try another one. We have milk spilled on the floor, running that. And then you can see the search results. And then the last one is person cleaning the floor. So there we go. All right, so that concludes the demo. And the cameras supported from the Axis portfolio, you can find them at the link on the screen. Axis has up to 50 cameras you can select from. These cameras have the system on chip such that they can run AI models and applications. And then the chips available are the ARTPAC-8 and the CV25. So smart cameras connected to the cloud are here, but how about the brownfield cameras? These are the cameras that run on video management systems. So as long as the video management system can upload the video to the Azure Blob Storage, the same search and summarization capabilities are available. And these capabilities are available at aka.ms Vision Studio. We have this only as a UX playground at this point. We are building the APIs for this as well. If you go to Vision Studio, you can try it with videos of your own. We've tried this extensively for safety and security scenarios, but you can try it with videos from any domain. And then if you want to sign up for the private preview API capabilities, which are coming, I would say, fairly soon in the coming weeks, then there is a form that you provide your contact information, and we will let you know when these are available. All right, so now let's jump into computer vision for modern retail. So the retail use case that I'm going to talk about are first loose produce recognition, or actually, in other words, fine-grained recognition of fruits and vegetables on a weight scale. We'll talk about how computer vision for shelf analysis can enable shelf restocking, and then all the way for how retailers can be compliant with planogram descriptions. So while the large foundational model has the vast knowledge, in the real world there are always challenging use cases. And we've all been at the grocery store and we purchased like produce, and then we all had to punch in like the code of the produce and then finding like what's the name. And what if a model can actually do that for you? So with model customization, with few images per label, you can train a custom model that can tell apart like fruits and vegetables. So in this case, it can tell apart a sugar beet apple from a Honeycrisp apple or from a Gala apple, something that I as a person cannot do, but you can definitely train a custom model that they can do that for you. So the model customization with the large foundational model enables fast path for customization. It has what we call few-shot learning, meaning that you can train a model with minimum amount of data. You can bootstrap a model with as little as one single image per label, and then you can continue to improve the model through the active learning loop through production data, or the model can learn continuously from new use cases. In the interest of time, I do not have a demo for model customization. Tomorrow there is a demo session for Azure Computer Vision. I invite you to join me there, and I can show you the steps that you can take to train a custom model. So we've seen how computer vision can help with retail scenarios for something like loose fruits and vegetables. Let's talk about how retailers are looking to improve operations, retail operations, such that shelf analysis is something that they can manage through computer vision. So through these APIs, the shelf analysis product understanding, you can actually pass images that you can take either with a mobile device or with cameras installed in the ceiling. And then out of the box, the model is going to give you product detection. It's going to give you the bounding boxes of the products versus the gap in the shelf. So it's going to give you, products versus shelf, and this is something that retailers can use for things such as shelf restocking. If you train a custom model where you can provide a single image per label and you can use images of the product catalog, you can train a custom model where the model is going to return you not only the bounding box of the model, but also the name of the particular product. So in this case, you can see like the position 14. And then in this case, we are using the example of training a model with the name of the product, but you can actually use the UPC code, which is something more practical for a retail solution. So let me show you this. Before I do that, the last one is planogram matching. So in the retail world, retailers need to organize merchandise on the shelf using what they call planograms. And these are descriptions of the physical shelf with the actual dimensions of the shelf and the actual dimensions of the products. So the planogram matching API can take in a planogram definition, and then it can match with the pixel level recognition of the product recognition API. So it's going to tell you whether the pixel level recognition from the API before is actually matching the physical dimensions of the shelf. So actually, let me show you that in a quick demo. So we are again in Vision Studio. And then let me select an image here. And then this is the model. This is the API that gives you shelf versus, gap versus product. So this one is going to give you the bounding boxes of the products versus the gap. And then in Vision Studio, if you go to the JSON tab, you can actually see the JSON response of the API. So in this case, it's going to tell us that a product with a bounding box, and these are the pixel level coordinates of the bounding box, is going to give you a classification of the type product. If you train a custom model, the way I mentioned before, and I have here a sample one, then the recognition of the product is actually going to tell you the actual name of the product. So assuming that the custom model has been trained with the names of the product themselves, then you can see the actual recognition of the product. So in the JSON response, you can see the classification response, the classification result, and you are going to pick the one with the highest confidence. So excuse me. So in this case, we have Nabisco Ritz Original Classic Crackers, which is like one of these ones on the top. So let's look at planogram matching. And I apologize, I'm doing something wrong with the mic. OK, so let's select the same image. And we have here the planogram description. So let's take a look at the JSON. We have a product ID placed on a fixture ID at position 1 inch and 61 inches, meaning that if the origin is the top left corner, then this would be the product. Let's see if I can scroll. This is the fixture, and then this would be the product over here. So actually, let's look at the fixtures. And then this is the first fixture, and it has a height in inches, which is the height of the shelf, and then the width of the shelf also in inches, and then is located at x0, which is like this point here, and then y69, which is like the distance from the origin to this point here. And then if we look at the products, we see that the product ID 006 is a Triscuit cracker, pepper, olive oil crackers, which has the physical dimensions of the box. So we have 4.9 inches and 7.8 inches. So this actually is position number 1, which is the one over here. Now, if we look at the matching result, it's going to tell us that the matching results show in blue. So these are all results of matching the planogram, where the product recognition of the bounding box is matching the planogram, and then it's going to give us that on this position there is a gap. And then if we look at the JSON response, then we can see on the position 001, which was the one at the very bottom, which is this one here, is been matched with the detected object, which is the bounding box with the pixel level recognition, and with the classification that the label is a Triscuit cracked pepper, which is matching the planogram. So these kind of APIs are the APIs that retailers can use to build their own solutions to improve retail operations. And we've been working with Blue Yonder, which is a retail operations leader, who are actually using these same APIs to build their own solution. And I want to show you a quick video for them to share their progress. So let's roll the video.
I'm Andy Hawkins, Product Director at Blue Yonder. And we've all walked into a store and found it difficult to locate a particular product. Where shelves get untidy and disorganized, customers are less likely to purchase what they'd intended and may decide to shop elsewhere in the future. When this happens, how does the retailer get to know? Our customers are asking how cameras and computer vision can help reduce the time shoppers spend searching for products and ensure the store is always well stocked. Direct analysis of shelves and shopper behavior can help create an environment that is both pleasant and efficient for their customers and store workers. At Blue Yonder, we've been working on a suite of capabilities we call Merchandising Edge. And for cases like this, we've been working with Microsoft to integrate with Azure Cognitive Service for Vision. With partners such as Microsoft, we have a roadmap of services on the Blue Yonder platform that integrate Edge devices with Blue Yonder products. This roadmap started with category management and store execution for use cases in grocery and convenience retail spaces. Our approach is to upload images from any source into Azure for interpretation. These images could come from fixed cameras, mobile devices, or roaming devices. The AI models detect gaps in the shelf arrangement, as well as individual product labels. And crucially, for the shelf analytics we're doing, the model is also capable of determining the physical dimensions of items and shelves. The interpreted data we get from Azure is fed into a set of Blue Yonder microservices that can compare reality with plans and intentions, such as allocation and positioning. But of course, reality doesn't always stick to the plan, and no one likes being told a bunch of stuff is wrong or could be better. So instead of generating a disorganized and somewhat endless to-do list, we assess each issue for relative importance. Now, importance can come from several factors, and here's a good example. A shelf gap is detected, but what were the causes? We can see an expected delivery was late, so the shelf hasn't been replenished as usual. And this location has high traffic, and the items usually sell well. So in this case, it would be better to fill the gap with a substitute item recommended based on trends like purchase patterns and shopper preferences. All these data points combine to provide a signal to change something as a priority. These signals can be made available through APIs to use within a task management app. And overall, our aim is to optimize the efforts of workers in the store and ensure customers do not leave empty-handed. But then, what if these temporary changes turn out to be better overall? In this case, we want the shelf analytics to suggest changes to the planogram itself. Integrating Azure with these edge devices and services with Blue Yonder's category management and space planning software means retailers can make more informed decisions about product placement, which leads to increased sales and better product visibility for customers. All up, a nicer shopping experience, better layouts, tidy stores, happier customers.
All right, so that was Blue Yonder. So this brings me to the end of the retail section and to the conclusion of our session. These capabilities are available in public preview. You can try some of these capabilities, or most of these capabilities being in public preview, you can try for free. We've talked about how you can manage digital assets, you can enhance safety and security, and you can automate retail operations with computer vision. We believe that the power of Azure Vision AI is connecting the physical world with the digital world and translating what one sees in structured data to empower solutions to the real-world problems. So I invite you to go to aka.ms Vision Studio and try it with your own data, and then use it by using our APIs from where you can find links, and then you can find documentation. The last thing that I want to leave you with is other resources. Excuse me, and I want to call out that tomorrow I'm going to have some of these demos and more in the Transform Your Applications with Vision AI. So join me there for additional capabilities. And with that, I'm going to stop here, and I'm going to take Q&As. So we will take questions that have been submitted. So the first one is, does any Axis camera work or only some? So these are cameras that have compute capabilities. So these are the cameras with the system on chip, and there are 50 models that you can select from. And these models are available. I cannot remember the link on top of mind, but you can find it on the slide. So that's where you can go figure out what are the exact models that Axis supports. And then the Microsoft ACAP Axis application is already onboarded on Axis Connected Services. So through this integration, these cameras can actually stream a video to the Azure cloud. OK, let's go to the next one. What is the pricing model for AI using Axis cameras? So the pricing model is actually pricing for the video storage and pricing for enabling video search and video summarization. We do not have the pricing announced for any of these features because they are still about to be released in private preview. So that is going to follow, but the pricing structure is going to be pretty much around storage and indexing and summarization. The next one is, for sensitivity healthcare-related human functional behaviors, is it possible to deploy AI models at the edge so no video has to go to the cloud, perhaps using NVIDIA Orin Edge GPUs? So these capabilities with the large foundation model are at this point enabled in the Azure cloud. These are large models that require GPUs, but we are looking to bring these capabilities at the edge as well. And especially custom models that can be trained for specific use cases. We are looking to enable this in private preview where the models can be packaged in Docker containers and they can run at the edge on GPUs such as GPUs from NVIDIA. So that one is coming as well. Does the automate retail operations only recognize the first outside row, or it can recognize depth of products further in the shelf? It is the first facing. It's the one that is visible directly to the camera. It's not going to go beyond like the first one. OK, I'm waiting for the next one. What are the challenges or considerations for practical applications in the field, speed of service, and so forth? I think like the biggest one is when you're looking at images, it takes like a quick trip to the service, and of course your network latency is going to add to that. But images, I don't think this is a challenge. I think video, it's a challenge. I think video recording and minimizing the network traffic, it's a challenge, which is why we are investing in this pre-processing of the video with smart cameras. And then I think there are the broader challenges coming from responsible AI. We are trying to take care of these challenges by training the large foundational model with curated data so that we can abide by responsible AI principles from Microsoft. But use cases, they have their own documentation and use cases for responsible AI. So that is something that I would actually call out and something that I encourage you to find information about the use case and responsible AI when you look up the information about the feature and the documentation. OK, going to the next one. I cannot see the full question. OK, I can see it. Can Vision AI track items across the video example? I have 2 chairs in the room. I want the AI to recognize chair 1 and chair 2. So at this point, we have spatial analysis, which is enabling video processing for live video. It has recognition for people, and we are also adding capabilities for vehicle. And then we're looking to add capabilities for custom models where you can train a custom model with its own object detection. And this way, we can enable like tracking as well. So these capabilities are enabled only at the edge because, like I said, streaming live video to the cloud, it has its challenges. So if you are interested in tracking people and objects at the edge, I would recommend that you look up spatial analysis. With the vector search, where are those images sourced? Any copyright issues by using those images in an app? So the images that you've seen on Visual Studio, those are there for demo purposes, and those are images that we have the permissions to use. The whole feature is built such that you can bring your own content. So the idea here is that you have your own photo libraries or your video libraries, and then you enable vector search by enabling similarity between text and images or image to image. I didn't mention, but the same way you find similarity between text and images, you can do it by finding similarity for one image against other images. So the whole idea there is that those images are there for the demo purposes, and then if you want to use this feature, you come here with your own content in your own applications. OK, 20 seconds. Are all the indexer capabilities working in live streaming or just for on-demand? At this point, it's for on-demand videos only. So, okay, the last 10 seconds, I want to thank you for being here. Please try out these capabilities. Let us know how it goes, and we'll see you tomorrow if you can join me for the demo session. Thank you.